we can't find two capacitors, very difficult. With one capacitor we can manage. Many unknown things will come. We have to solve differential equation, everything. Initial only.
Okay, sir.
Tomorrow I'll discuss few questions now. Okay. The EMF of cell varies with time as E equal to alpha t. Is connected in a RC circuit. As shown at t equals 0, switch S is closed. Find the current through capacitor at any time t. Look at the EMF of cell. It varies with the time. So now slowly you try to pick up problems where the EMF of cell varies with the time, the resistance varies with the time, the capacitance varies with the time. Then how that charging of capacitor still goes on. So let's take the circuit here. Why the resistance will vary with the time? Due to many factors, due to temperature, due to many other factors will be there. No? So as current flows, heat will be generated. Due to that heat itself, the resistance will increase. Already I've come across in the resistor chapter. Then the thermal expansion. There are many parameters are there which will lead to the variation of resistance. So there's one more, you can say like a troublesome for engineer again. So this is what strictly this is alpha t. So the current, let it be I plus minus Q minus Q. So writing loop equation, plus C minus IR minus Q by C 0. This current is responsible for growth of charge across capacitor. So therefore I equal to plus dq by dt. E is what? Kt. So what is the question that is asked? The question that is asked is to calculate the current through the circuit at any time. So shall we do one thing? First we'll find out the charge, then we'll differentiate it. So this K, where K is some constant, it is. So I can write it as dq by dt. Can you integrate this? Is it possible to integrate? We can integrate, but since you were not taught, for your syllabus it is not there. We can integrate this also, like a second, third order, all that one with constant coefficients. Part like it's like a particular integral. Some method is there. We can integrate where we with some second order solving second, third order differential equation with constant coefficients. Nth order differential equation also we can solve it. I think in your syllabus it is confined only to first order. So therefore, to avoid this integration, what I do is rather than writing this mathematics, we don't know mathematics, how to better way say like a out of syllabus. But still we can solve. So I'll instead of going for like this now, I equal dq by dt, let me differentiate this. I differentiate this equation. This will become k differentiating with respect to time, k minus di by dt 1 by c dq by dt equal to 0. So what is dq by dt? So we can go for replacement now. K r di by dt I by c. I think this can be integrated. K minus I by c is equal to r di by dt. Kc minus I equal to rc di by dt. At t equals 0, current is 0. At any time, let it be current I. So this will become minus log of So you must be very careful about any other possibilities. Definitely nobody will ask you where you don't know that mathematics. So you must search for any other alternative. So minus of log of, substituting upper and lower limit, I'll end up this one, minus T by RC. So the expression for I is equal to
Sir, on
K's.
RHS it is plus T by RC only, sir.
Yeah, yeah. So this should be 1 minus I by Kc e to power of minus T by RC. Okay, this is the expression for here also when the current will increase exponentially. What we had, the charging, the earlier circuit, what we had like the current will decrease exponentially, you know. So look at here now. The current in fact will increase exponentially with the time. Then when the current will be constant, when the current after a long time, so there's also one possible circuit. So now what happened? Get ready for the different types of problems where the EMF of cell will be increasing, R will be increasing. So this was the required one. So directly you can